Okay, welcome to parts 7 and 8 of the Algebra 1 review packet. Let's dive in. We've got systems of equations here. If I remember correctly, number 54 is not very pleasant to solve, so please just bear with me. I wish it was nicer, but here we go. So for this one, the best thing we're going to have at our disposal, I think, would be elimination. But as you can see, we don't actually have anything that's ready to eliminate right off the bat. So I'm going to take this first equation here and I'm going to multiply it by, let's multiply it by 4. And then what I'm going to be doing by doing that is I am going to cancel out the y's. So if I multiply everything in this by 4, I get 12x plus 8y equals 8. And then I'm going to be adding 9x minus 8y equals negative 4. Those cancel out. I get 21x equals 4. Divide by 21, divide by 21, and like I said, this is not a super nice one to look at. So your x is going to be 4 over 21. So now what we have to do is we have to go back into one of our equations. I'm going to pick the first one and plug in our x value to solve for y. So, I'm going to do the first equation because it has smaller numbers. So I have 3, and then x is going to be 4 over 21 plus 2y equals 2. The nice thing about this is I can do some canceling here. So I get 4 over 7 plus 2y equals 2. Like I said, not very nice. But I subtract 4 over 7 from both sides. It's going to help me if I turn that 2 into a fraction with a denominator of sevenths. So we get 2y equals, 2 is going to be 14 over 7 minus 4 over 7, which is going to give us 10 over 7. I'm going to move up here. 2y equals 10 over 7. And then I divide by 2. And that's going to give me y equals 10 over 7. And when you're dividing, remember you flip the other guy and multiply. So I'm multiplying by 1/2 really. And I get y equals 10 over 14. So if you wanted to properly put your answer together, you're going to put your x value and then your y value into a point because the solution to a system of equations is a single point. Okay, moving on from that nightmare, we have a much nicer question for number 55. It is giving us a y equals something, so the easiest way to solve this is going to be substitution, and that's where we just plug in this where we see the y in the other equation. So I'm going to do that. 6x plus 2 times, now I put in the negative 3x plus 1, and parenthesis equals 10. I simplify. Oh yeah, and then this one, the 6x and the negative 6x, they just cancel out, and I'm left with 2 equals 10. Well, 2 doesn't equal 10. So this is an example of when you get no solution. There is nothing that I can do to make 2 equal 10, well, in this equation, and so it's no solution. 56, same kind of deal. Let's do some substitution. We've got 7.5 times 2x minus 2 equals 15x minus 15. 7.5 times 2x is going to give me 15x minus, this gives me 15. And so now we have the opposite problem of 55, where we have the exact same thing on both sides of the equation. So if you get this, this is all real numbers. Or we also call it infinitely many solutions. All right. Systems of inequalities. So this will be fun to do on my iPad because I can do multiple colors. Remember, when you're graphing inequalities, the inequality sign that you have dictates where your shading goes, but it also dictates if you have a dashed or a solid line. So I'm just going to go ahead and graph the first inequality that I have. So my y-intercept is 2, and then I need to go up 3, go there, and then over 1. So there's my 2 points. And this is going to be a dashed line. So it's not going to look great, but you get the general idea. And then if you have y is less than, that means you're going to be shading in all of the less than, so the lower half of the y value. So we shade in all of that. All right, and the next one is y is less than or equal to negative 2x plus 1. So now our intercept is here, and then we go down 2 and over 1. This one has a solid line, so let's see. It's pretty good. But it's also a less than. So we look at our y-intercept here, that's how we're determining this, and we shade everything that's lower than the y-intercept, so below the line there. And you can see this area right here where they both are shaded. That is our solution. Moving over here. You guys, please stop. Shh. Every time they hear a car, and we live in the city, so it's not good. Negative 2, and then we're gonna go, let's go up 3 and then back 1. 1, 2, 3, back 1. This is a dashed line as well. Oh, that's not it. That's better. Then we've got y is greater than, so we're going to be taking from the y-intercept and shading everything above the line. Yay. Now, okay, this last one is a bit of a bummer. It's in standard form, so we could solve it using just the intercepts, I guess, but I don't want to, so I'm just going to turn it into slope-intercept form really fast. So I subtracted 2x from both sides, and now I'm going to divide by negative 3, but since I'm dividing by a negative, what happens? My sign switches. So this turns into positive 2 over 3x for my slope, plus, minus 2. All right, so I graphed that, and I've got the same intercept there, and I go up 2 and over 3. And it's a dashed line as well. And where do I shade? I'm going to look at this equation because that's the one that makes it easier to see. Y greater than, so I'm shading everything that's greater than y. And this intersection here is your solution. All right, thanks for watching. Hope this helped.